Hi everyone, today we'll be exploring a diagram of the human body and also a labeled model of the human heart. Both these activities are perfect for Year 6 students. These are very engaging and very fun, something that Year 6 students will absolutely love. Before getting into the hands-on task, it was really important for me to have my students already have enough background knowledge so that they could feel confident in these activities. We began with the class discussion about the human body. We discussed the organs that they already knew and had knowledge on, and we discussed what we thought each of these organs do. Naturally, this sparked curiosity amongst the students and activated their prior knowledge. Students also gained knowledge through visual slideshows, short videos, and short hands-on activities. Before getting students to build their own models, I planned a few simple hands-on activities to get them thinking like scientists and make real-world connections. First up, we did a fun little pulse check. Students found their pulse, timed it, and then did a few star jumps before checking again. Straight away, they could feel the difference, and that naturally led to questions about how the heart works. Then we did a body mapping task where students labeled major organs on a body outline. It helped them visualize where everything sits and made it easier to understand how body systems connect. Lastly, we explored a basic circulatory model using tubing and colored water. The kids loved this one. It was simple and really showed how blood flows through the body. Before I even started planning these activities, I asked myself, how can I make this fun, hands-on, and actually exciting for my students? I wanted something more than just worksheets. I wanted them to explore, build, and learn through experiences, and I knew teamwork and creativity had to be at the center of it. And in order to do this, I eased in my students by completing the human body diagram. So we are going to start off with the brain. It controls everything we do, like thinking, moving, and even breathing. As you can see, the brain is located right here. Now we're going to move on to our lungs, located here in our body. So these help us breathe by taking in oxygen and getting rid of carbon dioxide. So the heart is centered in the middle of the body at the top near your chest. The heart pumps all over our body and it carries oxygen and nutrients. So we could see that our stomach is labeled right here. This is where food is broken down. After we eat, our food is stored right here in our stomach. So our liver is right here. It's this dark brown, dark red organ that we got here. The liver cleans our blood and helps digest our food. So we got our kidney located right here. They clean our blood by getting rid of waste and making pee. So the small intestine is just located right here. So this is where most of the nutrients from food are absorbed into the body. And then above the small intestine, we have the large intestine. We have the dark green around here. The large intestine, this takes out the water from leftover food and gets rid of waste. Now that we've understood the main organs of the body, we are now going to move on to the heart and the circulatory system. For this assignment, I started by researching how to create a 3D model of the human heart. I looked online, mainly on Amazon, to find all the materials I would need, like Play-Doh, foam boards, toothpicks, and pipe cleaners to represent different parts of the heart and circulatory system. Luckily, everything arrived the next day. Once I had all my materials, I began constructing the heart, making sure to keep it simple but realistic, just like how a Year 6 student would do it. While building the heart model, I realized it was actually a lot more complicated than I first thought. To make it easier, I watched a YouTube tutorial that showed step by step on how to shape the heart, the main arteries and veins using Play-Doh. Once I had a clear idea of what I was going to build, I began by assembling the foam pieces to create a strong base for my model. I used a hot glue gun to carefully attach the foam sheets together and create an open cube design. This setup gave me plenty of space to place the heart model in the middle, which also leaving room around it for labels, arrows, and extra decorations. Next, I used my red Play-Doh to carefully construct the human heart. I followed the step-by-step tutorial from YouTube, which helped me to understand where each part of the heart should go. At first, it was a little nerve-wracking because I wanted everything to look as accurate as possible, but it actually turned out to be a really fun experience. I am now adding the superior vena cava. This is a large vein at the top of the heart that carries deoxygenated blood from the upper parts of the body, like the head, neck, and arms, back into the heart. Now this little guy down here, that's the inferior vena cava. Right now, I've only added the red part, but there's a blue section that I'll add later on. Together they show how this vein brings deoxygenated blood from the lower parts of the body, like your legs and stomach, back to the heart. It might seem small, but it plays a massive role in keeping everything flowing properly. This part here is the pulmonary artery. It carries deoxygenated blood from the heart to the lungs, where the blood picks up fresh oxygen. You can see how it branches out to both lungs, left and right. The biggest red section at the top is the aorta, the largest artery in the body. It's like the main highway for oxygen-rich blood, carrying it from the heart to the rest of the body. These three little branches at the top represent the arteries that send blood up to the head and arms. I had to really rewatch this YouTube video over and over again to make sure that I created the thin and detailed veins that I was going for. The pink veins represent the coronary arteries, which are super important because they carry oxygen-rich blood to the heart muscle itself. Without them, the heart wouldn't get the energy it needs to keep pumping blood around the body. These blue veins were fun to add. They are the coronary veins. Their job is to take the used up blood from the heart muscle and send it back into the heart so it can head off to the lungs for fresh oxygen. Now that I've finished building the heart model, the last step was labeling. I had to double check a few things by googling the correct parts of the heart to make sure everything was accurate, especially with the veins and arteries, which can be a bit tricky to tell apart. Once I had all the correct labels, I stuck them on and added a heading above the model for a clear, finished look. I really loved placing the heart model inside an open cube made from foam board as it gave neat structure and kept everything in place. The model itself shows a circulatory system in action, where the heart pumps blood around the body, sending oxygenated blood to our organs and returning deoxygenated blood back to the lungs. This hands-on visual is perfect for Year 6 students to help them understand how our body systems work together to keep us alive. Safety was a key focus in this project. I used the hot glue gun carefully on a heat-safe surface, avoiding touching the tip, and let it cool before packing it away. I also kept sharp tools like scissors safely stored when not in use. This model ties into several outcomes from the 2014 Stage 3 syllabus. So let me just quickly screen record this moment because confession time, I made a little mistake during assignment 1. I used the wrong syllabus, not once, but twice. Actually, no. 3 times. Yep, 2017 syllabus 3 times in a row. But thanks to Leslie's guidance, I finally got it. Thanks, Leslie. Anyway, so this time I'm using the 2024 Science and Tech K-6 syllabus. And honestly, these outcomes couldn't be more perfect for what I had planned. As a future teacher, I know how important it is to not just stick outcomes onto a lesson, but actually make sure the activities bring them to life. Building the human heart model directly links to ST3 Science 01, where students learn how body systems work to keep us alive, and ST3 DDT 01, that's all about designing, building, testing, and improving your work, which we've done through this whole process. And of course, ST3 CWT01 is all about communication, annotated diagrams, clear instructions, and this video itself is all about that. So everything I'm doing here isn't just meeting outcomes, it's helping me practice how I will deliver science in a real classroom setting. After matching up my activities with the right outcomes, I wanted to make sure that my approach wasn't just creative, but it was backed up by evidence. So I did a bit of digging and I found a study from Superlink found that hands-on science activities actually boost creative thinking in primary students. Another study from 2019 showed that when students do experiments instead of just watching or reading, their understanding improves, especially in Year 4. And a 2024 article from Taylor and Francis explained that mixing hands-on learning with visuals like diagrams builds stronger scientific reasoning. So I knew making these lessons collaborative and creating this visual world for my students would be ideal in keeping them engaged, allowing them to have fun, and most importantly, wanting to learn. And that's my most important thing as a teacher. And we can see that students do actually learn a lot from collaborative teamwork and also hands-on activities. I did want my students to also love science as much as I do. This activity isn't just about building a model, it's about deepening understanding through collaboration and creativity. Students will work in small groups to design, build, and label their heart models. This not only reinforces the science content, but also builds essential skills like teamwork, communication, and critical thinking. To assess their learning, I'd have each group present their model to the class. They explain the functions of each part, how it connects within the circulatory system, and use their label diagrams to support the explanation. That way, I can see what they've learned, not just by what they've made, but how well they can explain it. This task has really shown me how powerful hands-on inquiry-based learning can be. I love that this activity is not just about understanding science, but also loving science. I've learned so much by just planning and designing that it has given me an idea of the kind of teacher that I want to be when I do teach science in the future. Thank you for watching my video.